Let's start with the disclaimer first. Hello everyone. Today we will define our requirements. So we have our first requirement, which is a client can read data from sensors, and it will be related to the client side, which is later on should be connected to the kind of application or main server. So I have created a second requirement, client can send data to main server. It is a bit obvious, but it should be as an obvious requirement probably. Then we have third requirement, which is client and main server. I will use main server in quotes. It will be a reference to our local server or maybe an application or maybe a containerized server, but it is a main server in our case. It is just application which is loading clients and then collecting data or polling data. I have added another requirement, main server can display data. I think that we can add in the description that for now just printing it into the console, later on might print it into the log files, but if we are talking about containerized server and be able to connect it to one of the displays, I think we should add the requirement like main server should support an extension towards dashboards. It might sound a bit strange. A main server should have a way to interact with dashboards. It means that we should architect or we should design the main server to have a modular structure and maybe using some factories. If you know this design pattern like a factory, then to be able to tune what type of the objects it should create, to be able to display data, and it means that later on we can just add another class inherited from that interface, and then inside that class that we will create, we will implement the code to interact with dashboards and upload results to, for example, Google or something similar. I think we should also add another requirement, and it is it is possible to control main server means that we can send a command again via console or maybe using some requests or maybe some message sent to a main server, and then main server should react on it. So our basic requirements, let me think about it. I have added here two requirements. A client can be run without physical sensors. It will be needed for the end-to-end testing in the continuous integration pipeline or maybe in cloud or maybe in our local tests. Let's imagine that you are a developer who doesn't have sensors right now available and you would like to just run the code with some mock class and see how does it work, and then, for example, verify that the logic is correct. That's why we should have the requirements number 7. Client can be run without physical sensors. So it means for the development purposes, for the verification purposes, for the demonstration purposes, etc. Then I have added the requirement number 8. It is possible to use new sensor type without changing the client logic. It means that we need to design the client code in that way that for the new sensors type we just need to inherit a class, maybe a couple classes from the client, and implement necessary methods instead of rewriting the client logic. So we will have client's logic and a way to communicate with main server untouched, and we just extend it to a new sensors type in ideal world. one of the comments here. I understand that the client's logic is kind of depending on the sensors type. I totally understand it, but I mean most of the logic of client should be untouched. Let's think about possible use cases and corner cases. Assume that we have a sensor, this sensor became a bit glitchy and starts to send really strange data or maybe some wrong data. So we should be able to control the set of values displayed on main server, right? Requirement number 9. It is possible to configure the data displayed in main server. So returning back to the example, if we get a sensor which is glitching and sending wrong data, maybe instead of the adequate temperature in the room, it's sending some Kelvin temperature minus 273. So it means that main server can either completely ignore a client and just don't read data from it, or it means that main server can receive data from a client but just don't display it or don't react on it. I was wondering about a way to store data from clients, for example, within 5-10 minutes, and probably it is a nice feature. I think that we will not use any database yet, but we can add a couple requirements here. I have added 2 more requirements. So main server should store data from clients in RAM. So main server is running on the somewhere, for example, 1 day, 2 days, 1 week, 1 year. Clients are sending data to a main server, and main server should remember dates and probably update them, for example, or maybe for last 1 minute, 5 minutes, for example 30 minutes, 1 hour, maybe 1 day. Of course, data is coming constantly, and in that case it means that we should have allocated buffer and we should rewrite data from client. We should not store it as a new value every time, otherwise we will be out of memory quite quickly within a couple of years. But yeah, no. And then we have requirement number 12. It is possible to use database to store data from clients. We can take it a bit separately and a little bit later. Once we complete our containerized work and etc., then we can think about adding a database to store data from sensors. That will be quite interesting part of the logic, and it will require some refactoring and also some workarounds, etc. Maybe we will decline or reject this requirement. Who knows? Let's see. Talking about the communication between main server and client. Main server and client can use TCP, UDP or any other protocol to transport data. When we are talking about local server and static clients, again, under static clients I mean the static libraries which are linked to a binary on the compilation time or linking time, and when we run an application, these libraries will be loaded as well automatically. Under runtime pluggable clients I mean shared object or dynamic load library, DLL, which can be loaded in runtime. Then under remote clients I mean, for example, clients which are connected via TCP or UDP protocol, or maybe by using some different transports, for example HTTP or maybe remote procedure call or RPC. Containerized server and containerized clients means that we can run it in a Docker container or maybe in Kubernetes. Then we have control, it is test coverage, end-to-end testing, continuous integration. I think in our case, to be able to work with JIRA, etc., we can create a couple requirements related to the testing. For example, it is possible to test main server and client as end-to-end test. I think related to the unit testing, we can write it as well. Now it is a bit controversial requirement. Test coverage for unit testing should be greater than 30%. There is a problem. In some programming languages, for example Java, C#, or some other object-oriented programming languages, usually developers are creating a class, and then due to encapsulation we are writing getters and setters functions. We have a variable, and the variable which stores a value usually has private or protected access field, and to get a value we should implement function get that value, and if we want to change it we can write set value. And in that case, with getters, setters, constructors for example, or some other corner cases, I know that quite often it is related to the bad architecture, but instead of focusing on the important functions, properly test them. Developers trying to achieve this 100%, they are covering some boilerplate functions by tests, and we are kind of writing tests just to have tests coverage and not to cover the quality. Again, there is always question of the balance. It should be a balance between test coverage percent and logic behind all tests cases implemented. So in our case I wrote here should be greater than 30%. It means that we will have at least some test coverage, maybe not 100%, and it is fine. Okay, we have a client can read data from sensors. We haven't specified what exactly type of data can be read from sensors, but it is fine for us. Client can send data to main server. Client and main server should use versioned API. Main server can display data. I think for our example we will not use any users because it is relatively simple project, and to get access control for example, then we will need to have a database, we will need to figure it out, roles, maybe some other stuff, authentication problems to store data. It will be add more security perspective. I think for this project it is not really needed to add user management and user authentication. We can just keep it as it is. So we just assume that if you run a program then you have proper permissions. I think that this set of the requirements is enough so far, because if you remember the work breakdown structure, as said before, planning the work, implementation, control, they are kind of iterative processes. It is not just one-time action. We will return it back and then we will revisit what is happening. So the requirements should be discussed with stakeholders, with customer, with investor, because it might affect on the project. We will revisit the requirements a bit later if we find out that something is wrong or something is missing. Now the question is related to the architecture. So architecture is our next step. I think that I will make a pause here, so to keep videos shorter of course, and then we will jump to the architecture. Thank you for your time. Bye.